Hello everyone. Today we are going through lecture 19 of our Calculus 1, which is gonna be about limits at infinity or horizontal asymptote. So, what is the limit as positive or negative infinity? What is the limit of the function as x approaches infinity? Just like this function, you see this function x is very large. We don't know how much is x. It's very large. It's approaching infinity. Or the limit when x approaches negative infinity. So what happens to my function if x gets very large in either the positive or negative sense? In this example, you see that x is getting large in the positive sense in here, and it is approaching a horizontal line y equal L. This horizontal line, we call it a horizontal asymptote. It's a line that the function approaches when it is approaching, for example here, positive infinity. And we will soon see that the limits may also have an infinity value. So limit at positive infinity. So let a function be defined on a certain interval and the limit as x approaching infinity equals a value L. This means that the function f of x, the y value, is arbitrarily close to the value L as x is very or sufficiently large. Just like this one. As x is getting large and large and larger, the value of the function is approaching the value L, which is a horizontal line. What about this one? This one is an oscillating function. As you can see also, as x is getting large, the value of y is approaching this horizontal line, which is y equal L. What about negative infinity? In this example, if you look at the left-hand side, you see that as x is getting closer to large negative values, we can say it negative infinity. Also, it is approaching this straight line y equal L. And we call it limit as x approaches negative infinity equals L. What about this one? The same. The function as x approaching negative infinity is again approaching the line L. Alright, what about this function? This function, I have a left-hand side of the function and I have a right-hand side of the function. The left-hand side, as you see, x is approaching negative infinity, y is approaching, what is the value of y? It's approaching this line, which I think y equal 1. What about this one? As x approaches positive infinity, y is approaching negative 1. So this function actually has two horizontal asymptotes. Y equal plus 1 and y equal negative 1. Alright, what happens when we are solving limits problem? There are rules for solving limit problem as x approaching infinity. The first rule tells you that the limit x squared as x approaching infinity, you can simply know it by doing direct substitution. Infinity represents a huge number, any huge number you can think of. So a huge number squared will still be a huge number, so it's plus infinity. A negative huge number squared, you know that the square will cancel the negative sign, so it's still going to be positive infinity. As x approaches negative infinity, x cubed, you know that when the power is even, the negative sign remains, and then infinity power 3 is going to still be infinity. Any constant multiplied by a huge number is going to still be at the same huge number. And the limit as x approaches infinity of any constant is the constant itself. For example, limit as x approaches infinity of 5 is 5. Other rules. Limit as x approaches infinity of 1 over x. 1 over infinity is what? 0. What about 1 over negative infinity? Because this one, x is approaching negative infinity. Still going to be 0. So the limit of 1 over x to the any power, r represents any power that is positive, still going to be 0. Let's do these ones very quickly. Limit as x approaches infinity, 1 over x, 0. Limit as x approaches infinity, 1 over square root x. Well, square root of infinity is still going to be infinity, so 0. Limit of x approaches negative infinity, so 1 over negative infinity cubed, which is still negative infinity, till 0. Alright, let's do this one. Limit when x approaches infinity, 4 minus 3 over x squared. Alright, you know properties of the limit, you can distribute it to the terms, so it's going to be limit when x approaches infinity of 4, this is a constant, so it's going to be 4, minus the limit when x approaches infinity, 3 over x squared, 3 over infinity, right, is going to be 0. You know the rules, 1 over x power r is 0. So here it is, 4 minus 3 times 0, so it's 4. So there is a horizontal asymptote at y equal 4, or the limit as x approaches plus infinity equals 4. Another rule for polynomial functions. In polynomial functions, either positive or negative, factor out the largest power. So I'm going to check the largest power and I'm going to take it as a common factor. If an arbitrarily large number is multiplied with any number, it's still going to be the infinity. Right? Infinity times any number times any constant is infinity. So let's do it. The limit as x approaches infinity, 2x power 4 minus x squared minus 8x. Let's check what is the highest power. Here it is, x power 4. So I took it as a common factor, x power 4, and I wrote my equation as it is. So it's 2 minus 1 over x squared minus 8 over x cubed. Alright, take into consideration that you took the x power 4 as a common factor. So 1 over x squared is going to be 0, 8 over x cubed is going to be 0, so it is the limit when x approaches infinity of x power 4. Infinity to any power is still infinity, times the limit of these. Limit of a constant will be constant, this is 0 and this is 0, so it is infinity times 2, so it is positive infinity. Another example, and he's giving me 3 different brackets multiplied by each other, limit when x approaches infinity. Alright, infinity minus 2 is still infinity, power 4 still infinity, infinity plus 1 infinity, power 3 infinity. Infinity minus 1 will still be infinity, so infinity times infinity, it's positive infinity. Alright, so what I'm doing is just direct substitution. The same one, but x approaches negative infinity. Alright, here I need to take care of my power. Is it even or odd? So negative infinity minus 2, still negative infinity to the power 4 will be positive infinity. Negative infinity plus 1 is going to be negative infinity. Okay, think of infinity as a huge number. A huge negative number plus just 1. Still going to be a huge negative number. Power 3, okay, odd power will not change the sign, so it's going to be negative infinity. And then here, negative infinity minus 1, still negative infinity. Right now, it's just like multiplying 2 negative numbers together. Negative times negative will give me positive infinity times positive infinity is going to be a positive infinity. Right? If I had 3 negative signs, it would have been negative infinity. Here comes another rule. This one is for rational functions, when you have a polynomial in the numerator and a polynomial in the denominator. If you try to do the rule of taking the highest power as common factor upwards, which is x power 4, and then taking the highest power here also, which is x power 4, you will end by infinity, which is indeterminate. The value of it is another indeterminate, so I need to change the form. So in rational functions, I'll divide both numerator and denominator with the highest power in the denominator. So here, highest power in the denominator is x power 4. So I will divide up and down with x power 4. So I will divide here by x power 4. So this will be 2 minus, this will be 1 over x squared, and this will be 8 over x cubed. Here they are. Divided by, I will multiply down by x power 4, so this will be negative 5 plus 7 over x power 4. Remember, when you have the x in the denominator, it's 0, so this term is 0, this term is 0, and this term is 0. So you will end up with 2 over negative 5, so it's negative 2 over 5. So I have a horizontal asymptote at y equal negative 2 over 5. Another rule. If I have a polynomial function with a square root, we use the conjugates. So let's solve this one. Limit when x approaches infinity of this term. So I have a square root. Alright, so I will use a conjugate. So a conjugate is the same term, but you changed the middle sign. So it became the same, and I changed the middle sign to positive. And you have to multiply up and down. So what's going to happen to this term is going to be the same without the square root. So it's going to be x squared plus 1. Here it is, x squared plus 1. Second term will be the multiplication of the second term. So it's going to be x squared and a negative sign. So it's x squared plus 1 minus x squared. I can just cancel those x squared and I'll be left with plus 1. What would happen to down is going to be the denominator term of the conjugate. Here it is. What last step do? I just do direct substitution. So here I'm left with 1. Here I'm left with the whole term. So infinity square will be infinity plus 1 still infinity. Square root of infinity still infinity plus infinity still infinity. 1 over infinity is 0. Right here is another example. I'm having the same equation, but one time I will evaluate as x approaches positive infinity, and the other I will evaluate as x approaches negative infinity. So I need to, as this is a rational number, I will divide by the highest power in the denominator. Highest power in the denominator is x. But also make sure that x is the same as square root of x squared. This means that when I divide the upper term, since it's under the square root, it's as if I'm dividing by x squared. Because x squared under the square root is the same as x, the initial power that I want to divide with. So this is one thing to note. The other thing to note is that the limit as x approaches negative infinity, if this is negative infinity, which I'm going to do in here, I'm going to add a negative sign outside the square root function. Because I can't put the negative inside the square root function, so I just put it outside the square root function, and this will also account for the actual value that the square root of x squared could be a positive or a negative x. Alright, so let's do the first one, which is x approaches positive infinity. I will divide up and down with x. So here I divided the denominator by x. It's 5 over x minus 2 upwards. I will divide, since I have a square root, actually by x squared. So it's going to be 3 plus 6 over x squared. So I'm going to end up with negative root 3 over 2. In here, the same denominator, but upwards, since this is negative infinity, I will put my negative sign outside my square root. So I will end with root 3 over 2. So here I have a horizontal asymptote at y equal negative root 3 over 2 when x approaches positive infinity. There is another horizontal asymptote, y equal root 3 over 2 when x approaches negative infinity. Here is another example. Alright, another rational function with a square root. So here I need to divide by highest power in the denominator. Highest power in the denominator is not x squared, it is actually x. Because x squared and a square root both cancel the square root and the power 2, they cancel each other. So actually the highest power is x. But is it a positive x or negative x? Well, he didn't tell me if it is positive or negative infinity, so I need to actually evaluate both. So the limit as x approaches positive infinity, I'm gonna here, okay, divide by just x. So it's gonna be minus 3 plus 1 over x over square root. Since I have this square root, I know I'm dividing by x, but under the square root is gonna act as x squared. So it's gonna be 1 plus 1 over x squared, and I'm ending with negative 3. For the other side, which is the limit as x approaches negative infinity, I will divide by negative x. So the upper term will be just the same. Minus 3x plus 1 divided by x, so it is minus 3 plus 1 over x. But right here, because I have a square root and I have x squared, I have to put my negative sign outside the square root, and then I divide by x squared, and I'm going to end up with 3. This means here I have two horizontal asymptotes. I have a horizontal asymptote y equal negative 3 as x approaches positive infinity. I have another horizontal asymptote y equal 3 as x approaches negative infinity. And this is actually how it looks like. On the positive sense, x is approaching positive infinity, y equal negative 3. And here, as x approaches negative infinity, y equals positive 3. Alright. Another example, he didn't tell you to evaluate the limit, he said find the horizontal asymptotes. And you know that a horizontal asymptote can be evaluated if you do the limit as x approaches infinity. He did not say a positive or a negative infinity. He didn't say if I have one or two horizontal asymptotes. So I need actually to do both. But what rule will I use? Well, this is a rational function, so I will divide by the highest power in the denominator. I will divide by x. So I do the first one. Here the limit as x approaches infinity. I will divide by x. So I'm going to end by 3 plus 7 over x over 2 minus 5 over x. So I'm ending with 3 over 2. Here I have the limit as x approaches negative infinity. The same rule, I will divide by highest power in the denominator, which is x. So I'm going to end with the same. So here the two limits are identical. So I have actually one horizontal asymptote, y equals 3 over 2, as x approaches positive or negative infinity. This is another side of the story, which tells you that sometimes as x is huge, here the value of x is increasing, reaching infinity, what's happening to the y? It's actually reaching positive infinity. And here as x is approaching negative infinity, the y is also approaching negative infinity. So the limit of x cubed, the function, as x approaches positive infinity, it's positive infinity, and the limit of x cubed as x approaches negative infinity is actually negative infinity. And you know that we usually report infinity as does not exist. So I actually don't have any horizontal asymptotes. So here is telling me to evaluate the limit as x approaches infinity of sine 1 over x. So this is a tricky question because if you can do direct substitution. You can find an angle of 1 over infinity. So here we just need to make a twist. So I introduced the term and I say that let this 1 over x be equal to t. And as x is actually approaching infinity, as x, the denominator approaching infinity, this means that t is equal to 0. And I rewrite my equations in terms of the new variable t. So I say that the limit, instead of saying x approaching infinity, I'm going to say t approaching 0. And now it became sine. Instead of 1 over x, I will call it t, sine t. And I do direct substitution. It's sine 0, it's equal 0. This is the same idea that I need to twist my function. So here the limit when x approaching infinity, x times sine 1 over x. Well, I cannot say what is sine 1 over infinity, but I can say that I will let 1 over x equal t, and as x approaching infinity, t is approaching 0. And I rewrite my new function. So it's going to be the limit as t approaching 0. And now x equal 1 over t, so I wrote x instead of it 1 over t, and this is sine t. So it became sine t over t. Do you remember the rule? Sine anything over the same term equals 1. So sine t over t equal 1. This is the last slide in our lecture, which is about evaluating our limit when x is approaching positive or negative infinity, or finding the horizontal asymptotes. See you next.